The Honorable, the Deputy Dean of Finance, Faculty of Engineering, Universitas Negeri Semarang, Dr. Sri Haryani, MPD, who cannot attend for some reason. The Honorable, the Head of Chemical Engineering Department, Faculty of Engineering, Universitas Negeri Semarang, Profesor Dr. Dewi Satya Karyati, STMD. The Honorable, all the Chemical Engineering Lecturer of Universitas Negeri Semarang. The Honorable Mr. Steve Hyslop, Director, Chief Executive Officer of Continuum Energy, who can attend for some reason, and Mr. Ramon, Director, Sustainability and Operation of Continuum Energy, who will be our speaker today. The Honorable, all invited guests from Riset in National who took the time to attend this event. And our beloved, all the participants who took the time to attend this event. First of all, thank goodness, Alhamdulillah, Syukurillah to Allah yang Almighty, who has been giving us mercy, guidance, and happiness, so we intend to participate in this event with the blessing of God. Praise and celebration to our Prophet Muhammad Sallallahu Alaihi Wasallam that we always wait for his guidance. Chemical Engineering 2023 is proud to present Studium General with topic Circular Economy of Sustainable Waste Management. Before we move to the next agenda, we would like to introduce ourselves as the master of ceremony of the Studium General. My name is Indra Satipanistu. And my name is Amelia Pipi. At this special event, we have several agendas, but before starting our agenda, let's explain the agenda schedule of this event. Ladies and gentlemen, the first agenda is opening. The second one is grading. The third agenda is agreement signing. The fourth agenda is documentation. The fifth one is the main event. And the last agenda is closing. Well, ladies and gentlemen, the first agenda is opening. Let's start our agenda today by saying basmalah together. Bismillahirrahmanirrahim. The next agenda is the screening of the national anthem of Indonesia Raya. For the audience, please stand up. Ya, nggak usah pakai itu, langsung latihan. Indonesia.
Tangannya gitu-gitu. Hah?
The audiences are pleased to sit back. Thank you. Okay, ladies and gentlemen, the second agenda is readings. The first reading is from the Deputy Dean of Academic Faculty of Engineering Universitas Negeri Semarang that will be delivered by Dr. A. Gigi Prasetyanto MD. So, for Pak Gigi Prasetyanto, please welcome. Assalamualaikum warahmatullahi wabarakatuh. Morning, everybody. First of all, I would like to welcome Mr. Ramon Skane, Director Sustainability and Operation of Continuum Energy. Welcome to Faculty of Engineering Universitas Semarang. I would like also to welcome Steve Hyslop, Director and Chief Executive Officer of Continuum Energy, and I would like also welcome Pak Nugroho Anissa Songko, PhD, Director of Research Center for Sustainability Production System and Life Cycle Assessment. Welcome to Faculty of Engineering Semarang. I would like to convey sorry from our dean, Professor that he cannot attend this event because he has another agenda that in unit. And also, I would like to thank Prof. Selfie, Prof. Vicky, and all of chemical engineering lecturer, and also all of the audience, the student of chemical engineering department. Many thanks for your collaboration that come to our faculty to make this a special event circular economy of sustainable waste management. Uh, we are very welcome to collaborate with the Continuum Energy and also with the Research Center of Sustainable Production and Life Cycle Assessment. Uh, I hope that this is not the last event, but this is the first event that we hold together, and we will continue with the more fruitful and more strong collaboration between us. And also, I would like to introduce our faculty. We have five department, and also we have around 200 lecturers, and we have a big, very huge student body. So we have in total 6,200 students. So it's a very big number of students. So this is the if you have a many kind of research project and so on, we can collaborate together. So we can collaborate with the Department of Civil Engineering. We also have a Department of Electrical Engineering. We have also Department of Mechanical Engineering, and also we have a Department of Chemical Engineering, and very special for Faculty of Engineering, we have a home economy. This is a very special in Semarang because we
we are also known as a teacher training university. So we have people from the departments. And now our system will become a bigger and bigger because this years we will have 1,700 students and more. So we will have around 7,500 students, and also we will open a master degree for chemical engineering and civil engineering. We also already plan to open artificial intelligence magister program. So we are continue develop our faculty, and we are welcome to collaborate with all of you. I'm sorry I forget to say warm welcome also for all of the researcher from BRIN. I'm sorry. Then we are a very close institution with the university and BRIN. So with this event, I hope that we will start a strong collaboration. I think this is the introduction that I convey to you. And many thanks, and I hope that we will have a stronger collaboration in the future. Many thanks. Terima kasih semuanya. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Reading will be delivered from Kepala Pusat Riset Sistem Produksi Berkelanjutan dan Penilaian Hidup for Mr. Nugroho Abdisatoko, PhD ITU. Thank you.
Very good morning, everyone. Thank you very much, Pak Dekan, on behalf of Pak Wakil Dekan Akademi. And also so this lecturer from UNNES. Thank you very much for welcoming us this morning. So my name is Pak Selasa. I'm the head of the Research Center for System and on behalf of Hidup Research and agencies here. And also I on our trip Central Java and Jakarta, we along with our trip some of the researchers from our research center here Bu Forta, and other senior researchers from it, and also very welcome Mr. Ramon, my colleagues. When I was studying in Australia, I did in my former laboratory in and also in Perth. Let me introduce our research center first, and for the second, please. Next. Yeah, next. And next, our scope of activities, we are running some research activities on the innovation and research on the life cycle system analysis on the product level, like product assessment, product design, and also for the middle level, we also run the project on the industrial level activities and global web framework like supply chains. And we also develop the national database on the life cycle inventories, including the blockchain itself. We develop also the methodology measurement systematic dynamic assessment of temporal, spatial, and cost impact for the environmental, economic, and social performance. We call it as the sustainability, including the eco labels, product information footprint, product declaration, carbon cycle, carbon footprint, carbon neutral, and all of the related activities through all of the life cycle aspects, the life cycles. We also conduct some the activities on the sustainability services. Recently, we have some project to justify the sustainability of the money, the bank uang. Di kami juga melakukan sustainability assessment mana yang lebih better, uang kertas atau uang plastik. Simple, tapi ternyata sangat rumit karena 90% bahkan 100% material uang kita itu semuanya ini menarik. Memang jelas tapi ternyata sangat rumit dan sangat kompleks. We also recently have the project with the Australian company and also academic institution. We developed some project with geopolymers, and also recently our colleagues from Australia, Ramon, did the initiative of the project on the RDF. So after we visit Semarang, we will visit Banjarnegara and also Cilacap. So we have a trip along of the Central Java from Semarang, Banjarnegara, Cilacap, and back to Yogyakarta and Jakarta. And the last, we also run the activities on research on the circular economy, including the local project. Please next slide, please. Yeah, we have 11 research group. The first research group is the sustainable assessment, eco-design, and industrial ecology. And then the second is the research group on the life cycle analysis standard. The third is the sustainable industrial system and green engineering. And then the next is sustainable agency development and low carbon development. And then the next also the sustainability and life cycle analysis including industries. And the next is the life cycle engineering and next week. And we have also run the project of sustainability and life cycle of smart agriculture and forestry and fisheries, and also computer special data acquisition and public system. One day before we mention about the master degree on the artificial intelligence, we have also the research group running on that specific issue. Blockchain recently we ran the project. And we have also the research group on the circular economy. Next, please. And the Semarang research. We have two research groups located in Jakarta, one located in Semarang and Yogyakarta. First research group is group environment and sustainable agriculture system located in Semarang, and the one before circular economy located in Yogyakarta. And in the last research group, we also have the industrial ecology and environmental social governance. And we in our roadmap to the future and also current activities, we also assist environmental social governance. The ESG agreement is very important for the companies. So since last year, we helped the financial institution and also the industry in around 100 companies to review the of the ESG report. So we run this project as well as the research. Next, please. One day before mention about the student body, I remember I also assessor in international accreditation Pak. Saya asesor IAB, saya asesor lab teknik, saya asesor di Berkelanjutan juga. Nah, in educational degrees, we have our staff now is 130, not 120. Increasing, we have 5 new research paper. And we also give the opportunity to student both for the master and doctoral program. For the degree by program, we give the scholarship. So if the student from UNNES and also the lecturer from UNNES want to continue to the higher education by using the BRIN scholarship, we also provide the scholarship not only for the local university but also for the overseas. And recently we also accept more than for 14 postdoctoral. We give the opportunity to join with the research in BRIN for more than 1 year. It can be extended to be 2 years. So all of the expenses, including the salary, we cover. So every month from 16 juta rupiah. And we also accept the visiting scholars. We have 4 visiting scholars in our research institution between 3 until 6 months. We have some senior lecturer from Pusat and he starts UPN Jakarta and other students in Indonesia join as a visiting scholar in our institution between 3 until 6 months can be accredited. We also set the research assistant. So if Pak Dekan, Pak Wadek recommend some of the student master and student to join in BRIN activities, we provide also the scholarship, the stipend every month is around for 4 juta rupiah for 1 year, and we accept the MPKM program. We accept around 20 students. It does not include from UNNES because of their special with the special program. So around this sector we have around 30 students for doing this in our institution. Next, please. Yeah, it's not updated yet, but until today we have more than 30 progress achievement from last year 2022 until now. So we are also the member of the UNNES of the UN Convention. Next, please. Yeah. So if you want to reach us and know more better about the institution, you can access our social media is now active. So you can get the updated information about our activities and also our collaboration from our social media and of course the big website. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
You. Next agenda is a document that will be signed by the representative from the Faculty of Engineering of Universitas Selasa and from Pusat Riset by the Riset Inovasi Nasional. Also, we will have an offer of mementos between Faculty of Engineering and Pusat Riset by the Riset Inovasi Nasional. For both representatives, please welcome.
Tidak bukannya khusus ada. Kalau itu suka ya kata saya IPN kata dan oke. Saya wajah para baca ini sudah
Oh,
tanda tangan.
Terus biasanya
Ya, itu ganti
biasanya
Satu dua.
ya. Oh iya.
itu merupakan sejarah Dekanat dari Fakultas Teknik Pusat Nasional. Selanjutnya dari Pusat Riset pada Riset dari pada perwakilan dari Fakultas Teknik jadi komunikasi. Oh iya. Kasih ya. Suatu ya. The sign, the agreement signing between Mr. Skane and also Professor Davis.
KPI. Ini buat akreditasi.
Betul, Pak.
Saya kalau jadi asesor yang saya cek itu soal.
Iya, kalau KPS, PKS enggak itu.
Saya kemarin yang akses elektroundik saya. Elektroundik sama elektrotelepon.
The agreement signing, the next session is the completion session that will be led by application. For the documenter, please welcome.
Right, everyone, please stand up for the documentation session.
Oh, dapat barang Pak Kapus. Datang sampai ada dokumentasan.
TTS.
Please, everyone, stand closer to each other.
Yes.
All right, 3, 2, 1. Fine. I go for time. 3, 2, 1. Birthday everyone.
Bayar. Tapi saya sibuk ya. Bos soal sibuk.
Oh,
Ya,
Saya calon.
tidak tahu. Politiknya tidak tahu.
Ya Pak, UNNES sudah bisa selesai nih. Iya. Sukses Pak, mudah-mudahan lancar.
Dan yang maaf ya.
For the structurally with topic of circular economy and sustainable waste management. Yes, we have other that's arguments indeed that we have a lot of room.
Yeah.
Yes, the goal is identity. Para kemudian komunikasi lain itu tetap kantor. Tapi besar dalam kami untuk yang tidak sendiri.
Oh, iya.
Tapi jika ingin stay juga
Enggak gitu. Agendanya apa?
habis ini sudah lecture.
Ya udah enggak apa-apa.
Oh nggak apa-apa. Oh, ya.
Alright, ladies and gentlemen, we will move to the main event of this agenda. This is the main session that will be guided by Mr. Hanif Ardiansyah, SMT. Please welcome Mr. Ardiansyah.
Warahmatullahi wabarakatuh. Good morning, everyone. Ladies and gentlemen, welcome to the audience and study general collaboration between the Research Center for Sustainable Production System and Life Cycle Assessment BRIN and the Faculty of Engineering UNNES. The today's topic is about the circular economy of sustainable waste management. Okay, first thing first. I would like to welcome the key speaker and all of the participants. My name is Hanif Ardiansyah, and I'm the moderator of the session. Before we start, I would like to inform you that for some reason, one of the speakers, Mr. Steve, could not attend today. But there is no problem because we still have one speaker that will deliver the material to us today. Okay, I will introduce to you our speaker. He is Mr. Ramon Skane. Good morning, Mr. Ramon. Mr. Ramon Skane is Director of Sustainability and Operation on Continuum Australia. Ramon is an accomplished environmental engineer. Experience and knowledge from the water and circular economy industry, organizing for work in the industry and universities institution. Ramon has worked in numerous projects, including R&D, into the production and design and geopolymer eco-concrete production and its own production facility in Western Australia. Hydraulic production pressure analysis of water distribution and water balance modeling in Pilbara and photovoltaic reserve analysis water purification operation in India. And this time, Riset is the fact that the circular economy and renewable industries. Okay, if one of you have a question, you can ask him at the Q&A session. And now, please welcome Mr. Ramon. Okay, Mr. Ramon, the time is yours. Thank you, Sheldon Punky. That's my old lady's name, and I'm still laying, so I hope you don't mind if I do most of this presentation. First of all, thank you so much for having me on here. It's been a wonderful trip so far. Very big thank you to BRIN and Department of along with the BRIN research team and the University UNNES itself as well. That was also the first time I've heard the Indonesian national anthem, and it's a good national anthem, so it's very nice, yes. So again, thank you for having me here. I'm very excited and glad to be here. And today I'm presenting about two main technologies for circular economy. The first being eco-fuel, the combination, a modernized combination of waste energy and refuse fuel. This is more focused on those in chemical and mechanical engineering. And the second is on geopolymers, which is a alternative concrete material, which many chemical and civil engineers are interested in. Okay, so next slide, thank you. So just to sort of overview of the presentation. So I'm Skane, the Director of Sustainability and Operations Continuum Energy. In this presentation, I'll first introduce the company, who we are to do, and why we do it, along with the background of circular economies for these technologies. And then I'll look into the products themselves, so eco-fuel, what it is, why it's sustainable, why it's good, along with the scale-up trial we did in Thailand, where we've actually been making this material, how we would like to also do it in Indonesia. After this, I'll also look into eco-concrete, and then look at next steps. So next slide, thank you. So just quickly, the team here, this is the executive team. There's 5 people in the executive team, but many more. So I'm the second, Ramon Skane left. Steve Hyslop, I believe, is in the Zoom meeting now. Unfortunately, we've been traveling around Southeast Asia from business development, Thailand, Singapore, Indonesia, and Australia, and unfortunately, Steve got very ill when we were in Singapore. So he cannot join today, but he sent us apologies. I believe he'll be on the Zoom. So next slide. So essentially, Continuum Energy's core business is engineering project developments with a focus on renewable energy and circular sustainability. Our main thing is engineering. We also look into enabling and identifying project opportunities around the world, and we look into investment of engineering projects with a focus on sustainability. So our executive team has over 100 years combined experience in waste management, in-center project development, power generation, renewables and fossils from before, along with project delivery, civil and construction, and circular economy framework. So just as some examples, the team's been involved in commissioning a 350 megawatts wind farm system in South Australia. We've also been involved in commissioning hydro power schemes in southwestern Australia, along with the Rockwood, the Weir Dam project, and we've also been involved in some of the teams have been involved in large scale $100 million plus alumina modular refineries and so much more. So our team is very diverse, experienced in multiple fields, and Continuum Energy is a strategic consortium of multiple companies that have come together and focusing on big sustainability projects as well. So next slide. So just to quickly go over our values, the idea is to use all of our combined knowledge from our various industries to focus on sustainability and really improve social, economic, and environmental sustainability wherever we go. So we want to reimagine today's energy and waste management solutions to enable cleaner, greener, and healthy environments for us all. And one thing we really want to focus on is renewable energy, but also circular economy together. So we're especially interested in those technologies that can combine both. So next slide, thank you. So just a sort of background on circular economy and renewable energy industry, a quick background, a lot of you may already be familiar. So the world generates over 2.1 billion tons of municipal solid fresh waste per year. This is an enormous amount of waste. Most of this, obviously a lot of it is growing as years come. Now, most of it is dumped in landfills and contributes to a lot of environmental pollution, such as leachates, environmental issues, economic issues. And in Indonesia, since 2019, I've seen that about 190,000 tons of municipal waste per day is produced in one day in Indonesia. There's a lot of waste produced everywhere else. I've recently been to other countries in Southeast Asia, and they produce so much waste and have such little land to their landfills that I've even heard that some waste gets dumped straight into the ocean because there's no solutions for this waste. So we want to find solutions for this. Now, also, there's a bit of background of climate change and unsustainable energy usage in the fossil fuel industry. I presume most of us are already familiar with this background, so I won't go on it, but essentially, we want to look at technologies also that minimize greenhouse gas emissions. Now, to date, one technology is waste energy, and when it comes to producing energy whilst also minimizing waste, waste energy is one of the main feasible solutions at a large scale to deal with high volumes of waste, but it also has its issues. So waste energy started in the late 1800s and became popular after World War II. People incinerate waste to produce energy, but there's always a lot of there's an issue with waste energy such as pollutants, and when it comes to actually providing a solution to the waste, a lot of the times the waste energy is just a matter of throwing waste in, busting combustibles, any combustibles, and just hoping to produce power. Another technology is refuse-derived fuel, and this is focused more on getting the waste and cleaning it and separating it, and then combusting afterwards. But refuse-derived fuel also has issues with pollutants if it's not managed properly. So the main products we are pioneering is eco-fuel, which takes the advantages and pros of both waste energy and refuse-derived fuel, combines them both. So you can get a renewable energy product that also has the great hallmarks of social. So next slide, thank you. So next slide. There's a few animations, keep going. So with landfill, there's many issues. So obviously, there's a lot of CO2 and methane produced on landfills as well. Air pollution, greenhouse gas emissions, public health concerns. Do next 3 slides, thank you. There's also mismanaged waste materials and hazardous waste materials. This can get into the groundwater and pollute the land as well. Water pollution, aquatic species destruction. This can lead to issues in the fishery industry and the agricultural industry. Next slide. And obviously soil contamination when it comes to agricultural wastes. And this all leads to social, economic, and environmental hardship. Next slide. So the main products we're sort of trying to introduce is eco-fuel. And again, eco-fuel is a modern approach to simultaneous renewable energy circular economy. It combines the good of waste energy and the good of refuse-derived fuel. It's a modernized approach. And along with the ability to take fresh municipal household waste, we can also take landfill waste. And the reason this is significant is because most waste energy plants do not take landfill waste because it's too difficult to process. And whilst some, very few refuse-derived fuel technologies do take landfill wastes, they don't process in the environmentally friendly way. This product aims to address all the issues. So next slide, thank you. So what do? So we start with the population and we see how we questionnaire them and see how they produce their waste. Their waste is sent to landfill where we produce eco-fuel. That eco-fuel is replaces fossil fuels and diverse landfill. That produces sustainable electricity and renewable energy for the population. And as they produce waste again, it goes to the circular economy. And we also can use landfill monies. We actually make that circle even bigger. So next slide. So with eco-fuel production, we can do, like I said, we can do fresh and landfill waste materials eco-fuel. It's an environmentally friendly alternative which can replace coal, gas, and other fossil fuels in furnaces such as coal power stations, gas power stations, cement kilns, starch mills, anywhere with a furnace. And depending on the people that are using eco-fuel, it can completely or partially replace their fossil fuel usage. It can also, as we when it comes to transitioning away from fossil fuels, you can't just flip the switch, you can't get one off, you have to transition. And this is a good solution for easing that transition. Keep local community jobs and local sustainability going to the next slide, thank you. So just a simplified model of what we do. So we first Depending on if we go to landfill or fresh waste, we first mine the landfill or get household fresh waste diverted to our facility. This facility is processed and separated into combustible and incombustible material. The incombustible material is separated from the metal, the masonry, the aggregates, and can be given or sold to local businesses to use for circular economy. The combustible material is sorted and made into a combustible eco-fuel product. Hazardous materials such as asbestos, PVCs, and other materials are also directly separated and can be done with hazardous waste management facilities. The next slide. So some of the fuel stocks we can use is food waste and combustible. We can also use tires and rubbers, plastics, food waste, paper and cardboard, and textiles. This is the organic feedstock that gets made into eco-fuel. Next slide. And the inorganic materials that we can't make into fuel, we directly separate. So when you're in the landfill, the metals, the masonry, the glass, it's all mixed and you can't get to it. But we separate it directly so that people can access it. We stimulate the business. So next slide, thank you. And this is just a sort of process diagram of how eco-fuel can replace coal and gas powertrains. And as you can see, the process is much simpler and shorter, and we can combust it in any furnace to produce sustainable energy and make electricity. So you can turn already existing fossil fuel stations into transitional sustainable fossil fuel stations without decommissioning the whole power station. Next slide, thank you. So one of the advantages of eco-fuel is that with our technology, we can achieve high calorific values. Just in case anyone is unaware, the calorific value is just the combustibility of the material. Now, most common refuse-derived fuel technologies have a combustibility of around 3,000 kilocalories per kilogram. We have been able to achieve between 3,000 and 8,000 kilocalories per kilogram. This is just another modernized using modern machinery. We also can deliver a minimal carbon footprint. One thing we also do, we focus on supply chain analysis, life cycle analysis on our fuels to make sure it's as sustainable as possible. It's also because we're using waste material, we're not mining coal or extracting gas. Because we're using waste material and people want to get rid of waste material, it also leads to a cost-effective, cheaper facility that is good for the investors and for the local people as well. Eco-fuel is also a baseload and renewable power supply. So with renewable energy solutions like solar and wind, they're good, but they're not baseload. And we've seen some places in Europe where they switched very quickly to intermittent renewables and they've had issues with electricity prices. So this, alongside some other renewable energies, is also based. Next slide. So this is a sort of comparison of all the different fuel types. Some of the main fuel types. We have fossil fuels and modern gas. We also have solar and wind, pumped hydro and nuclear. And at the top is eco-fuel. And what you can see is that eco-fuel takes the advantages that made fossil fuels famous, such as baseload power and easily transportable material. And it also takes the advantages of renewable energies, such as solar and wind, where they're actually renewable. And we can also use waste as well. So it ticks all the boxes. Next slide. So this is what the trial we did. So recently we visited the trial in Thailand, and we conducted core drilling of a landfill and sorted the waste accordingly to make eco-fuel. The aim was to assess the feasibility and practicality and ESG sustainability of eco-fuel in Thailand, the potential facility is also existing, and the main reason is because Thailand is importing a lot of fuel, including coal from Malaysia. So next slide. So as you can see from these graphs, the latest data is 2021, and they're still importing a lot of fossil fuels. Even though they're trying to do solar and wind in Thailand, they're still using a lot of fossil fuels for that baseload power that their solar and wind can't get at the moment. So we want to address this with a sustainable baseload supply. Next slide. So these are some pictures from our operation. So as you can see, we drilled into the landfill. The landfill was about 50 years old. And from that, we got some core samples out. And you can see they're very wet, it's a black sludge. And then from that, we sort them according to textiles, plastics, metals, rubbers, and other waste materials. Next slide. And so from that, once we separate all this material, we did independent laboratory analysis of this landfill and found that with our process, we could get 4,700 kilocalories per kilogram or even 6,400 kilocalories per kilogram. It could also get higher. So again, this is compared with conventional RDF, which can only get 3,000 kilocalories per kilogram. Now, this low calorie per that regular RDF gets is one of the reasons you don't see RDF more often, because it is not cost effective, so it can't continue. But with ours, we can get a higher calorie per that makes it cost effective. It can also be made to exceed international and compliant environmental regulations. We also swap the landfill to get rid of heterogeneity, so it's similar, and it's feasible and comparable cost to fossil fuel. So next slide, thank you. So here is the independent laboratory documentation. The first two are the calorific values, and the last one is the amount of chloride. So this is particularly important when it comes to environmental pollutants, dioxins, furans, and that sort of thing. Now, conventional RDF facilities such in Southeast Asia usually have a fluoride weight percent of 0.3 to 0.4, sometimes even higher. Now, the particular, the cement kiln we were trying to target the off-take requirement had a specification of 0.6, but just to show if people think that RDF could be good, we wanted to show that it could be clean. We made sure that we could get our environmental pollution very low, and we got 0.13%, which was 4 times less, or 130% lower than its target specification. We can also go lower than that. We can meet international United States EPA regulations. So next slide. This slide sort of compares the feasibility of RDF. So the reality is, with renewable and sustainable energy solutions, that along with being green and sustainable, they must also be economically feasible so they can continue. And so looking at our table, we've seen that the cost of our waste fuel is comparable to cheaper fuels, which is good because it means it can be economically feasible. It also is similar in the kilowatt hour per kilogram, the efficiency of power. But again, depending on what the client wants, we can tailor-make the fuel to change the power efficiency or the amount of cost. Next slide, please. So this graph just sort of shows the price. The green line is the price, and the bar graph is the power efficiency. So looking at the green line, we can see that eco-fuel can be made to be cheap, so that when people buy it, they're not spending too much. Keep using this. And the bar graph shows the efficiency of power. So you can see that eco-fuel is similar in power efficiency to the other fuels, such as some of the fossil fuels and some of the renewable fuels. So it's comparable to fuels. And it's also cheaper also. Because the aim of making waste material, not buying circularity grounds. Next slide, thank you. So the environment's overview. It's very important to us, especially when looking at other waste energy and RDF facilities that are very bad when it comes to pollution. We want to make certain that environmentally our technology is sound. And so we did a lot of analyses on the environmental aspects as well. So the environmental aspects of the eco-fuel is very correlated with the waste that we're using. So depending on if there's biogenic carbon, so this is natural carbon such as the organics, that's be traceable, it can be in the carbon cycle. And there is also non-biogenic carbon, which is the carbon from plastics, carbon from polyester fibers that are not natural. And you find this in all wastes. So the cleaner the waste, the more it's separated, the better the sustainability of the eco-fuel. So keeping in mind that the eco-fuel we did in Thailand is a 50-year-old landfill, so it's sustainability is a bit different. First of all, we make certain that our eco-fuel can adhere to any environmental regulations. Our particular one in these trials we made to adhere to the United States EPA regulations. We can also make it in any other regulations. Now, unlike waste energy, we really analyze the waste and we sort it accordingly, separate as much as we can, so that even the stuff we cannot manage to do, the glass, bricks, masonry, stains, we can directly give to customers and put that back into the market for a certain good. Next slide, please. So, looking at the waste hierarchy, there is a most preferable to less preferable when it comes to waste. Now, on average, the global waste management system is around the bottom. They look at disposing and dumping in the landfill, which is not good. Eco-fuel is around the recovery stage, and the byproduct is at the recycling stage. Now, don't get me wrong, I think definitely the top ones, reduce reuse. If materials can be recycled first, yes, they should be 100%. But what about the material that's already in the landfill that we can't access, which is sitting? What do we do with that pressure? So this is the solution for those materials in the landfill. Next slide. Thank you. So we did a carbon analysis of the landfill materials. So we saw that. Next slide. So if the eco-fuel was completely biogenic and the waste was stored accordingly, such as in some modern Western Europe, you can get a carbon neutral eco-fuel. Now we found that the fresh municipal solid waste from primaries has a slightly higher carbon emissions when compared to carbon neutral, and then landfill, again, because landfill is 50 years old, there's different kind of waste in there, is slightly higher than that. Now obviously we want to aim for carbon neutrality, but it depends on the waste we get. Now one thing with eco-fuel is that we, from this, we can get carbon credits compared to fossil fuel usage, and we can communicate with the community to make sure we aim for the carbon neutral eco-fuel. Next slide, please. Now, one thing to focus on renewable energy and eco-fuel technologies is that although solar, green hydrogen, growing biomass is good for renewables, they don't divert landfill. There are two problems here: renewable energy and landfill. So eco-fuel has renewable capacity and land capacity. And it is made to be completely biodynamic, it can be completely renewable and completely landfill. Next slide. So from this, we got our engineering team and we modeled a eco-fuel facility. At this stage, it's a 240-ton eco-fuel per day, and it can use 1,000 tons of fresh waste per day or 660 tons of landfill waste per day. Eventually, we can make use of next slide. This is just sort of some of the international recognition, UN SDGs that we need, such as clean water, affordable clean energy, climate action partnerships. Next slide, just time to skip for this. And so when it comes to eco-fuel, what we're trying to do is that we want to make these projects around the surrounding world as well. We know there's already an idea for sleeping in Asia, and we want to be part of making the future of Indonesia with the environmentally friendly eco-fuel technology. We provide useful energy and diverting landfill. So no more plastics in the oceans, no more waste, no more running out of landfill. Whether it's using fresh waste or landfill waste, we can use both. So to get this going, we're here in Asia speaking with BRIN, and we're trying to look for more opportunities. It's been great so far, and we're talking to invest about potential projects and getting legal and environmental approvals. Next slide, thank you. Next slide. But that's it for the eco-fuel, thank you. With my remaining time, you've already said look into geothermal concretes. So this is particularly interesting to civil engineers. So first of all, just in case anyone is unsure, I don't know if people have made concrete before. Concrete has four main materials: cement, which is the glue that holds everything together; sand or fine aggregates, and then coarse aggregates is rocks and water. When you combine all of this, you get concrete from this picture. And this essentially is the most used product in the world. It's actually the most manufactured product in the world after treated water. It's also responsible for about 8% of the world's greenhouse emissions. The next slide. So look at the market for cement, which is that gluey material. Globally, it's $326 billion per year. Where I'm from in Australia, it's 1.7, and Southeast Asia 35, and Asia cements $200 billion a year. This is the biggest materials industry in the world. It's massive. Next slide. But how is it exactly made? Well, first of all, the cement, the glue material, is an a combination of limestone and plain sand soils. These materials are heated and burned at 1400 degrees in a giant kiln. And this produces so many emissions, 8% of the world's emissions. This is more than all the greenhouse emissions from all the cars in Asia, the United States, and Europe combined. It is one of the most polluting industries in the world. So when the cement is made, it is mixed and made into mixed with aggregates and made into concrete as well. Now, some conventional concrete, they've started using fly ash in it, but usually only replacing 10, maybe 20% of it. In my opinion, this is not enough. It's not using enough waste. So next slide. So what we do is we make eco concrete instead. And instead of saying 10-20% of the cement, we can use up to 90% of fly ash in our cement. We mix it with a small amount of chemicals to make the reaction a bit more faster. And from that, we make our eco cement. And we can use various waste materials such as coal fly ash, bauxite residue red mud, agricultural waste, rice husk ash, hemp pellets, and we make a cement material that incorporates 90% of waste materials and is responsible for 80% less carbon emissions than regular concrete. So again, 80% less for an industry responsible for 8% of the world's emissions. The next slide, thank you. Next, yep. So this is the concrete we made. On the left, the grey cement this is made from fly ash. On the right, we've made from fly ash and red mud. This is from the living industry waste. And then on the right, we made it from fly ash and also agricultural waste, big emerging industry in West Australia. We can also use mine tailings and other material agricultural waste. Next slide. So here are some of the other concrete we've done. On the right is myself. We made a slab, and the slab on the right. And in that slab is half a ton of industrial waste. In Western Australia, this has never been done before. We were the first to. And there's also 80% less emissions. So if I had that concrete slab here and a normal concrete slab there, the one I was saying next with 80% less greenhouse emissions and incorporate more waste. Next slide. So with eco concrete, the main cementitious binder is called a geopolymer cement. I won't go too much into technical detail, but it can be made into precast concrete that can be shipped or in situ poured concrete. It's also the financial bit depends on the local supply chains, what ways can be accessed. Next slide, thank you. But when it comes to making geopolymer, just to sort of the technical side of things, a geopolymer is essentially where you have normal polymers such as ethylene, which is a carbon-hydrogen combination to make substance polyethylene, which is plastic bags. A geopolymer is simply a combination of silicon, aluminium, and oxygen to make a geopolymer. Next slide. And what this looks like under the microscope. So this is a cold fly ash sphere. And as the geopolymer is made, next slide, you can see that they form, and then the activating chemicals form, and then all combined to make a long polymer chain, which is what gives the concrete its strength. Next slide. But it's so good, but why? Why geopolymer? Well, apart from the significant carbon savings, geopolymer, when it comes to the materials industry, is one of the best candidates for circular economy. No other material can incorporate as much waste as geopolymers. It can be made into, and because it can incorporate so much waste, and it can be used for so many materials in construction. Civil infrastructure, roadways, bricks, seawalls, concrete panels. It can be used for so many products, ceramics, fireproof materials, foams. Yes, so it can be used for a lot of different products. Next slide. So, in the interest of time, I might not go through with this, but this should sort of keep the technical side of what we do. So, a lot of the technical we do is we X-ray diffraction, and we do a lot of analysis on the waste materials themselves. Next slide, I'll just skip through this at the time. And essentially, when it comes to actually making this geopolymer, there's various steps. We first have to analyze the waste at if it's a power station, coal plant, or in the red mud from the aluminum industry. There's a lot of information on waste, how we can deal with it. And then from that, we do testing on it, X-ray fluorescence, X-ray tracking, go back. Thank you. Yeah, thank you. And then from that, we do testing on chemicals we use, the small amount of chemicals. And then we also analyze it and make a fit for purpose concrete that can be made into products. Next slide. So this is pretty much just showing the process we used to know. It's a very complex process, but it can make any concrete material that you like, incorporating a lot of waste. So next slide, thank you. Next slide. And that's it for me, just in the interest of time. But thank you for listening again. Hopefully, I'm really hoping that we can get Jim on the concrete and Pico still happening in Geneva and deal with waste material here and reduce carbon emissions. Thank you for having me. Lokasi and spreading the market. Thank you very much, Mr. Ramon, for the nice and presentation. So we know that the nuclear fuel and geothermal technology is a modern solution alternative to energy and circular economy that can turn fresh and landfill waste material into biofuel, a sustainable power resource made from waste anywhere in the world. And now we will reach the question and answer session. If you have a question, you can raise your hand and ask what your question. Okay, who wants to be the first questioner, please? Okay, Solomon.
Okay, thank you very much, Arif. I would love to convey my hearty congratulations to Mr. Ria for the beautiful presentation. My name is Solomon. I'm a chemical engineering student in University of Wisconsin. I took the privilege to follow your presentation in detail, especially on matters related to eco-fuel, and I found it a little bit more interesting and more sustainable for the human approach. However, I would love if you fill up my knowledge on two particular matters. One, as I realized from your presentation, that eco-fuel, is generated largely from waste and more particularly landfills. And if you look at the patterns of landfills in the world, and most of them are generated from the grassroots level. The approach that you have lectured on seems to be a little bit more sophisticated. It needs modern tools in order to enhance the eco-fuel. So my concern is what type of engineering model can be available perhaps in order to initiate strategies that can harness eco-fuel from a more grassroots approach that can be locally adapted. Is that in place, or can that be perhaps achievable in the future? Because if you look at the pattern, the more you have a local adapted product, the more you can be able to combat the impact of waste and its related management. So I would love to make some little clarification on that, and it is also one area of my curiosity. My second question, if I can be permitted, is on the pattern of the climate change, particularly from where I come from and the South Sudanese in Africa. We have had, first-hand impact of climate change, and much of these things are resulting perhaps the global warming, industrial related. So I was a little bit curious as that, contribute to a more generation of eco-fuel going forward, or does it have a negative?
Please all over the question. And you can answer this. So thank you so much. Great question. Thank you. So your first question on the actual land materials and how it was
So you're completely correct in saying that landfills is a different way to go. So it depends on the local community, it depends on environmental regulation, the country, sometimes different neighborhoods can have very different places. You're correct in saying what we do in our approach before we start building anything, because one thing I've seen, particularly with waste energy facilities around the world, is that you have very big engineering companies that just come into a country and they go, yep, we'll take this waste, yep, we'll take that waste, let's put a $100 million facility and just hope for the best. We don't want to do that. What we want to do is go to the local level, just like you say, survey all the people and really understand from the cultural level, what do the people eat in their house? What do they dispose of? Is it how much of this plastic, how much of this food? And what we want to do, we really want to understand from the lower level on in the local people to the upper level from industry, everything going into the landfills. And then we also do the testing, the core drill. So, some waste energy facilities don't do this core drill. They just make a giant facility and go, okay, let's throw all in there, incinerate it, and produce some electricity, but it's not optimized. We want to optimize it. And you're correctly saying that because landfills can be different where you go, you would need a different process, and that's what we do as well. So when we do our core drilling, we find out we do numerous, we can do 10, 15, 20, depending on the landfill, to get a rough idea of the landfill capacity. And from there, we get our analysis of the waste, and we can see, and then from that, we see what machinery is the best to deal with it. So a landfill in, for instance, Sudan versus Indonesia versus Australia might need different equipment, but we tailor-make the facility to make sure we can deal with it. And just to provide more information there for your curiosity. So, because one of the questions I get a lot of is, landfill is so heterogeneous, it's so different. How can you deal with that? How do you get quality control? And the reality is, it depends on the country that you're in. In places like where I'm from in Australia, when there's a lot of construction demolition waste and some hazardous waste, it's harder to deal with it, it's very different. But places in Southeast Asia, such as Thailand, where the food people eat is very similar, and the waste that goes into the landfills is quite similar. What we do is we usually assume around maybe if we go to a landfill, make sure that it's at least 8 years old. 8 years old or older. And the reason we do that is because all the biological chemical processes, so the aerobic action, or if it's a sanitary landfill, the anaerobic action, as a majority of it has already taken place. That way, the landfill is actually more homogeneous. If we go to a landfill that's 2 years old, those chemical processes are still happening. There's too much heterogeneity. But most landfills are over 10 years old, sometimes even 100 years old. But some of those processes have already occurred. So it's actually more homogeneous than you think. And a lot of the analysis of the drilling that we did at the Thai landfills also showed that. The fresh waste was obviously more homogeneous, but the landfill was also more homogeneous than even I originally thought. And your second question on the greenhouse gas emissions. So it's a very good question. And the reality is, when it comes to climate change, this is a very big issue and a very complex issue. Complex problem, need a complex solution, right? Now, people have been dealing it in very different ways. Europe, Asia, America, Australia. And the problem is we need baseload power. We don't, solar and wind is good, but when you have intermittent issues, the price of electricity goes up, and then usually it's the local people that suffer. Now, I know there's battery technology that's being innovated, and that's good, and all for that stuff. But again, the biggest thing for me, along with the climate emissions, is the landfill. But to answer your question a bit more directly, because look, make no mistake, some of the material in waste is non-biogenic and has an associated carbon footprint. Now, although this is significantly less than fossil fuels, it's still a carbon footprint. But what I very strongly want to eco-fuel is that when we make a facility somewhere, we also invest in the community, and we also invest in education, waste separation. What's the best, the best separation methods and the best ways to treat it, so that eventually, when the eco-fuel we make and the longer in the community, the waste sorting and waste management gets iterated to the point where the carbon emissions of the eco-fuel eventually goes down, and hopefully, realistically, it can be carbon neutral. Now, one thing I didn't present to you because I'm still working on it, but when we have landfills such as sanitary landfills, so these are closed landfills, usually lined, usually tapped, we have a significantly more amount of methane, and that's when you have different reactions going. Now, the question with eco-fuel, especially sanitary landfills, is that when you combust eco-fuel, you're offsetting the methane emissions from sanitary landfill. And for those of you who might be aware, methane it can get 25, 30 times worse than CO2. So by using the eco-fuel waste in place of the waste that we just degraded to methane, you can actually get a carbon negative product. So I have worked on this model as well. I'm still the team is still working on it before we present it. But depending on the landfill, we can also potentially get a carbon negative product. And I just want to strongly say that our approach is to carbon neutrality, carbon negativity as much as possible. Practically, before we get to that, we need solutions now. And we can't, because this is a base load power, base fossil fuels now, and it can also get rid of waste. And then as we innovate, and do R&D, we can actually get to carbon neutrality, especially carbon negativity. So we try to be practical in the present and the future. I hope that answers your questions. Thank you. Thank you.
Thank you. Anyone wants to ask another question? Okay.
Thank you, Mr. Raymond, for the explanation. It's really interesting to see that eco-fuel is really effective compared to other fuel. It's really interesting for me, but I have some question. I'm really curious about something. You mentioned in the slide that there's a separation process in the process diagram. I'm curious, where do the separated material go? And also, what is actually the main material to produce eco-fuel? Because there's a separation process, right? Yes.
Thank you for the question. Ramon, you can start to answer it.
Thank you for the question. Yes, good question. So essentially, when it comes to getting waste, there's a lot of ways you can classify it. But the most simplest way, just a quick conversation, is the combustible materials, so the food, organics, the stuff that essentially will explode, combust in a furnace, and the incombustibles, the bricks, the metals, the masonry, the cement, that will not. And obviously, you don't want this in a fuel because if you put that into a furnace, so there's a lot of waste energy facilities, you get a lot of ash, and sometimes you get a lot of emissions as well if the combustible. So, to answer your question was correct. So we have combustible and incombustible material that comes in the starting of the facility, and we have different separation machinery such as screens, we'll have trommels, we'll have air blowers, dryers. All these different materials are separated according to moisture, according to particle size, according to density, and all of these materials are separated. And the idea is we separate all the incombustibles out, but we don't just separate them and throw them in a pile, because that's just as bad as landfill. We separate them directly as much as we can. So again, according to density. So all the metals fall in one pile, all the bricks fall in another pile, all the sand falls into another pile, and this can now be reused, right? Before in the landfill, it was all mixed. It could not be used. And sure, there's some scavengers who try to get as many materials as they can, but it's just it's mixed. But with our process, the incombustibles get directly separated into different piles that can be reused, and combustibles that go through get sorted according to an average calorific value. Maybe it's a cement kiln or another furnace. They might say, we want 6,000 kilocalories per kilogram. And then depending on that, the combustibles that we've sorted according to calorific value, we mix them and ensure that it's shipped out, send that to a wherever the off-taker, the buyer is. And then as part of what we do with Continuum as well, we also monitor the combustion of this material as well. So for instance, one big thing that I get asked about is the environmental pollutants of this stuff, right? There's big waste. And particularly with cement, we have we also help with the combustion of CO2 to make sure it's environmentally safe. And the reason we do that is because, again, looking at older waste energy technologies, a lot of times they don't understand their waste. One of the biggest issues with average, especially older waste energy, is they don't analyze their waste. Just throw everything in, incinerate it, and hope for that. And so because we have such a good understanding of waste, we know exactly what has been separated, exactly the calorific value. As much as we can about what waste is in there, so we can know how to treat it environmentally. So we can tell them, okay, if you're going to incinerate this in your furnace or your cement kiln to produce heat for your cement, you need to go to this temperature, you need to go to this residence time, and the reality is in our experience, it's not unreasonable to ask those cement kilns. So cement kilns can be up to 1400 degrees Celsius. Now, if you do it correctly, 1400 degrees Celsius is enough to actually separate all the dioxins, the furans, the environmental pollutants. And if you go right through the whole process, you actually get very minimal pollutants at all. And the ash is also a nice white, clean white. You always get ash through the processes. I've been some waste energy facilities where the ash is black, filled with carbon, and the smoke is black, and it's just a mess. So with the environmental side, we also do a lot of talking with the customer to make sure that when this is actually being used, we are certain it is meeting environmental regulations or we're exceeding. So I hope that was a bit of a long answer. I hope that answers your question. Thank you.
Okay, thank you for the answer. Another question, please. Okay.
Oh gitu. Tapi itu ya Mbak, Mbak, makan teh ya.
So to be honest, I've been obsessed
Yang Mbak Ina itu.
Siapa?
Ina. Oh belum.
However, I have
Belum ada pembagian. Udah. Ini ada ini belum lagi ya. Cuman biasanya bayangin kan mau ngedepan Nugroho atau saya dari kayu gitu. Oh ya udah kan nanti saya tanyain misalnya Bapak ya. Ya, enggak. Ada. Itu Mbak itu Mbak yang kalau kita mau nge-zoom gitu, di sini punya fasilitas itu nggak breakroom. Oh karena dia. Jadi satu ini tapi bisa masuk kan? Nah dia. Ada kayaknya di sini di grup. Ya udah nanti Mbak Neng kirim ke aku. Siapa lu kata Mbak? Iya yang di itu kan yang di grup kan. Sip, thank you.
The last one of your question, the classification of the eco-fuel. So yes, we can also do that. So it's just another step. When it comes to the soils, they are also separated out in the process before. So because it's mostly inorganic form of waste, we separate that directly too. So when it comes to the combustible fraction of the fuel, the eco-fuel that is sent off to whether or not it's going to use it, and whether it's classified as well, there's almost no soil in it either. But if there's this, a tiny bit you can add that will usually form in the ash of the when it's combusted. And then that ash again can be reused as well. So it can be used finally like the geopolymer concrete, or it can be used in conventional concrete as well as a supplementary cementitious material. But yeah. So the soils, it's a good question. The soils we can separate, and the stuff that we cannot separate, a small amount, is formed in the ash, which can be reused. And yes, we can get it as well. I don't know if I answered your question. Is that okay?
I think the organic waste is about incombustible waste. How can manufacture the feedback or the sort of the eco field community.
Sorry, I couldn't hear you. There's a microphone.
Okay, you want to repeat it again? How can real organic waste mix organic waste? I think it's about incombustible waste mixed with the combustible waste, because organic waste can come such one the soil, the food, and maybe can make with waste in in manufacture or in the making of fuel energy. Yeah.
Okay, yes. So with the combustible, the incombustible kind of process, we separate as much as we can, and even with the combustibles. So we separate the incombustible metals, masonry, sand, as I said the gentleman before. But even the organics, the combustible part of the waste, we also separate this one. And then from that point is when we separate the combustibles and we circle that and circular economy. We also separate the combustibles, and then depending on who's taking the equipment, we will combine the combustibles in a way to get an average calorific value and then send that on. Does that answer your question? Okay, thank you. Okay, thank you for the answer. Another question.
Thank you, Pak Hadi. My name is Imelda Priyanka. Student. I have a question. Where does this was come from? Is there a clear layer of its restaurant material?
Yes, good question. It's a good question because, funnily enough, in some ways, with this product, the hardest part isn't too much the engineering. The hardest part is actually putting the stakeholders together. So, who do we get the waste from? Who do we sell the eco-fuel to? So, it's a great question. The engineering is one side, but the actual management of all the different parties is the other side. So, for our particular scale-up trial in Thailand, the waste came from a private landfill. Just north of Bangkok. It's about 50 years old, so it's a private landfill. We had an agreement and MOU with the landfill owner to use their waste. And then part of the facility we're making at the moment, we'll be giving that, we'll be selling that eco fuel to a nearby Skane job. That's a good question. But a great question because people always ask, engineering is one side of it, but actually getting everyone involved and ready to go is another part. And sometimes that can be more challenging. So great, yes. But depending on where we go, maybe we in Thailand we've had starch mills that have been interested. So recently, when I was there 2 weeks ago, they want to gasify it. Like you're saying, they want to gasify the eco-fuel and do their pumping for this. So the stakeholders can change. Yes. That's the question. Okay, thank you for the answer. Another question. Okay. Hello. Yes. Welcome to Smart Welcome to Indonesia. Our research group is making biofuels from waste in agricultural and coal waste. And personally, I'm interested in biogas. Yes. Why you choose solid form of biofuels and which one's better? Solid, gas, or liquid? Good question, thank you. And yes, thank you for having me at the university. The first question, in terms of solid or liquid, because we can make it to different, we have a very wide range of different values, and we tailor-made, we specifically make this calorific value life. Like some RDF facilities, other facilities, we can only get 3,000. We've asked the customer and they say, we want 6,000, maybe we want 5,000, maybe we want 4,000. Because we have such a good control of our process and the waste, we can specifically say, okay, we do 6,000 today, maybe the customer wants 4,000 next month, and we directly do that. So the point there is that the customer might want it in solar, or they might want it in gas. So it's really up to the customer. If they want it in solar, we can give it to them as a shred or a pellet. If they want it in gas, we can collaborate with them to gasify it and switch them to gas. So depending on the customer, we probably try to have a gasification process unit at wherever their facility is. That way they can actually store the solid and then gasify it whenever they want, so it's ready against use. So when it comes to what's better, solid eco-fuel or gaseous eco-fuel, the answer is whatever the customer wants. If they want solid, we can give them solid. If they want gas, we can give them gas. We don't discriminate. Gas, solid, all good. We're happy with it. It depends on the customer. Now, the first part of your question on biofuels, yes, biofuels is good. The only, I'm not sure exactly, like in Australia, we've been looking at biofuels as well from logging from trees. And biofuels is good, but personally, the issue I have with some biofuels, and this is in Australia, I'm not sure what happens here, is that they find a bit of land and they have to grow trees or forests in them, whatever, it takes how many months or sometimes years to grow, and then they cut it all down, and then they bust it and they make the biofuels, and they have different land plots everywhere, and the transportation sometimes can always change, there's always need resources, and that adds a cost. And the problem is with cost, that the higher the cost, the less feasible the solution, and then the solution can become unsustainable economically. And if it's unsustainable economically, it won't work. You know what I mean? So I think biofuels is different because you can also get biofuels fresh waste. Great, big fan of that. But in Australia, we're trying biofuels for crops, you know, and I don't think it's particularly efficient, especially because from my perspective, when it comes to growing crops, trees, or greenhouses, rather than using it in biofuel, because you're cycling the carbon, and it's carbon neutral, sure, but if you get the crop and you make it, say, into furniture, and you store the carbon in the furniture, then it becomes carbon negative. It's not just in a cycle. The carbon is on, the trees have absorbed the carbon, and they've gone into furniture, and now it's stored, it stays there. If it's in biofuels, it just keeps cycling. That's good, but putting it into furniture or products, in my opinion, is the best solution for biofuels, personally. But also, I just want to add to that. We're hoping with our collaboration with BRIN in Indonesia to do some landfill analysis, landfill BRIN, and feasibility, sustainability analysis of landfills or fresh waste, either in Indonesia. So depending on how things go, if anyone's interested, getting student involvement or collaboration with all of us, or just science documentation, we would also love to do that. So yes, thank you for your question.
Okay, thank you for the answer. Another question? Okay.
Okay, thank you for the chance. Let me introduce myself. My name is Muhammad Farhan. I'm a chemical engineering student. Maybe my question is just a basic question. We know that Indonesia have very big potential of municipal waste. That it can be converted to eco-fuel. That is very good if it can be implemented very efficiently in Indonesia. But we know that in Indonesia, the technology is still not very advanced, and the fossil fuel can be still available at least for the next 30 years. And my question is, how can eco-fuel compete with fossil fuel in Indonesia? Thank you.
Great question, thank you. So in terms of the technology, so you mentioned that some of the technology isn't as advanced in Indonesia. The solution there is just to bring the technology to Indonesia. So we're using very modern technology as part of that process. And if all things go well, we'll be bringing that to Indonesia. So we'll be advancing technology. So that's fine. We have suppliers mostly from Europe as well. Also The second part of the question, which was on how we can compete with fossil fuels. So you look at fossil fuels in the last 100 years. So, you know, when it comes to sustainability and carbon emissions, that's
Kebanyakan.
the real focus on relatively recent. But if you look at fossil fuel and what made them famous and what made them cheap, and what allowed them to provide power to many people, one of the main advantages of fossil fuels when it was being developed is that it can be stored, right? So, solar wind, but when it comes to
Jadi dia fokusnya ya yang cuma yang mudah-mudah. Terus
so in terms of how eco-fuel can compete with fossil fuels, we can store that solid material.
bisa gitu ya. Kita nggak abal zaman-zamannya dulu juga.
Mencari kerja baru.
Iya. Rada-rada kesal juga.
And another way we can compete is that, like, if so one of my slides detail the calorific value. The eco-fuel we've made similar to the calorific value of coal, sometimes actually better. So from memory, I think the average Indonesian brown coal is around 5,500 calories per kilogram. We made an eco-fuel to that. We've also made 6,000. So another competitive part to fossil fuels is we look at their calorific value, and we want to make ours as similar as possible. So the idea behind ours, eco-fuel, is we take the good things that have made fossil fuels so usable, and the good things in renewable energy fuels that make it sustainable, and we use both. So that's it. Thank you.
Okay, thanks for the answer. Still another question? Okay.
I just want to ask for explain my theories here. So you said that you go to live instance, which what we did. You also asked explain to conference here. Because I'm just really curious, like, what is the effect of the landfill type? Is this landfill enough to give me enough materials? Or is this one of the challenges for me to make it happen?
Great question, thank you. It's a very good question, right? Because it goes to the feasibility and these solutions to be sustainable that also need to be economic. So great question. The answer is that, to be honest, if you look at the amount of power that, so these landfills for Thailand, if you look at the amount of power in Thailand, there's actually not enough waste. So there's actually not enough waste to with a big amount of eco-fuel to make it power for the whole country. Now, sections of the country definitely do. Here, power stations there, but for the whole country, there's actually not enough waste, which sounds crazy. But our engineering team have done the numbers, and yeah, if we were to make it all, we would clean up the whole country with bricks, and it would be good if we could do it. There's actually not enough waste. I didn't believe when I first heard it. But yes, so the answer is we can, the landfill material that we sampled, we can use to make it feasible in Thailand. The material that we could use for the concrete, I think you mentioned at the start, we could also use that too. Now, in terms of the similarities of landfills in Thailand and Indonesia, they're more similar than you think. And we've done some brief research looking at some of the waste separated in Indonesia, and we found that a lot of landfills suit here as well. That's the question, but yeah, in terms of, you know, is the landfill suited for landfill facility? The answer is yes. We have made a pilot, we're making a pilot facility right now. We're currently talking to investors and collaborators, and they're very keen, and we're going forward, and we're hoping to also go forward in Indonesia as well. Yes.
Okay, thanks for the answer. There's another question.
Thanks for the for people feel teaching, we also currently from psychological progress. Teaching and they have planning of the process, we also have planning process, we also have in psychological progress. And they have, we also have put in film and they have small size. So main question is there any different and yeah, we have to feel except for the tech area because they keep your and then we'll small there. And what is the reason we have to feel then okay.
Thank you. Thank you. So a lot of your question was on comparing eco-food to RDF and how they're different. Good question as well. So the main difference between RDF and eco-food is the machinery we use. So a lot of I did RDF facilities in Thailand. I'm seeing one in Indonesia in a few days, and I'm seeing others as well in Europe. And the main difference with RDF is that they get the waste and they'll store it a bit, but it's not the ones that I've seen. They store it a bit, but the machinery is very good. To be honest, a lot of times the RDF facilities I've seen, they bought very cheap equipment. So for instance, the cheap shredders and then the actual blades in the shredders launch very quickly, and then you just make on Facebook. We're going to have times dry, they just don't dry enough. So one of the main differences between RDF and eco-fuel, one of the main differences is that with RDF, because so much of the machinery is not really up to standard, they get very low calorific values. So for instance, current values in Indonesia, I believe, is around 3,000. In Thailand, it's about 3,500. I've seen ones in China for about 2,500. And to be quite honest with you, I was in my facility 2 weeks ago in Thailand. You could not tell the difference between the waste coming in and the RDF going out. It looked the same. And again, it's not good. And again, it's because the machinery was not sustainable. They bought very cheap. I can't name the idea facility, they bought very cheap machinery. And so they're going to cheap. One of the main differences with eco-fuel is that we make certain, if it costs us, the reality is 3,500 kilocalories per kilogram. It's enough to be competitive with fossil fuels. It's not enough. It needs to be higher than this. Most calls are around 4, maybe 5, sometimes 6,000. Right? We can get to those levels. Conventional RDF cannot. Not the rest. Most of them cannot. So one of the differences is that we can get to higher levels. Another difference is that a lot of RDF they do not use landfill material. So most RDF usually fresh waste, and that's just because it's easier to store. But again, even because we have more complex equipment, we can also store landfill. It's probably a ton. If that makes sense. Thank you. Good question. Good question.
Okay, thanks for the answer. Another question. So thanks Ramon for the answer. Please give applause for Ramon.
I don't know. Just saw that Steve is online. You guys stay on the screen.
He is here. He is here. Stephen.
I don't know if you can hear us. That's okay. That's all right. Thank you for having me as well. And one thing I really just want to say as well is thank you for all the questions. Because a very important part of when it comes to sustainability, getting the energy, circular economy, you need to have a discussion. You need to ask questions. There's no such thing as a silly question. always ask questions. And I'm very glad to see that there's been so many questions in the audience today because it's extremely important. And sometimes, even when it comes to climate change, sustainability, it's very important to ask questions. I've been to some conferences, won't name names again, but I've been to some conferences where people have presented. It was an environmentally friendly concrete, and it was not environmentally friendly. They call it BRIN. And so I asked a question, and everyone sort of laughed. But the point is, you need to have that discussion. So it's very important. So thank you for all the great questions. Keep continuing to ask questions. Good luck with the studies, and thank you so much to the Lokasi for having me. Thank you.
And now we reach the end of the session, and I'm going to read the summary of our meeting today. There are many global problems, and waste is one problem that must be solved quickly. To overcome this waste issue, circular economy can be used to be free from waste. One of the ways is using waste as renewable energy. Eco-fuel and biopolymer is a promising technology that can contribute to a more sustainable energy future by converting fresh and landfill waste material into eco-fuel. Using eco-fuel can help reduce the dependence on fossil fuel, which can help to mitigate the effect of air pollution and climate change. Okay, I think that's all for today. And I would like to express my gratitude and appreciation to our speaker. Thank you. Thank you very much for giving us a new insight about circular economy for sustainability waste management. And I would like to thank all the participants for joining this study general. So I'm looking forward to meet all of you in other occasion. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Yes,
Thank you for Mr. Skane for priceless information and also all the enthusiast participants. Finally, we come to the last agenda, is closing and praying. To close this event, let's recite Hamdalah.
Deepest of my heart, it is something I do and my friend. Apologizes for our mistakes while presenting this event. Thank you for your attention. See you next time. Assalamualaikum warahmatullahi wabarakatuh.
Ini yang jenengan. Oh, dari sini.